Good morning, all of you. Welcome to C. J in the Rank Zone. In the previous lecture, we have completed about hard water and soft water, and how to purify, how to convert hard water into soft water. Now, in this lecture, we are going to learn about degree of hardness of water. So it's very, very important. Please listen carefully. From this part, you will get question numericals based on in the IIT advanced exam as well as in the mains exam. So let us see now what is degree of hardness of water. The degree of hardness of water is defined as the number of parts of mass of calcium carbonate equivalent to various calcium and magnesium salts present in 1 million parts by mass of water. So it's nothing but degree of hardness of water is nothing but amount of, that is number of parts of mass of calcium carbonate present in 1 million parts by mass of water. So it is nothing but number of parts of mass of calcium carbonate present in 1 million parts of by mass of water. It is expressed in ppms, that is parts per million. It may be noted that degree of hardness of water up to 100 to 150 ppm in water. So if the degree of hardness is present up to 100 to 150 parts per million in water required for daily needs such as cooking, bathing, washing of clothes, etc. is tolerable, and greater than this it is not tolerable. So if degree of hardness exceeds this limit, then water is not suitable for domestic use. So how to calculate the number of parts of mass of calcium carbonate in a given water sample? You can see mass of calcium carbonate is calcium carbonate. So actual 1 mole of calcium carbonate is equal to 1 mole of calcium carbonate is equal to, that is 40 plus 12 plus 16 is the 48 is equal to 100 grams. So in 1 mole of calcium carbonate we have 100 grams. Therefore equivalent, because they have told equivalent, so equivalent weight of calcium carbonate is equal to equivalent weight of calcium carbonate is equal to molecular weight by charge, that is molecular weight by 2, because the charge of calcium is plus 2. So it is equal to 100 by 2, it is equal to 50. 100 by 2 is equal to 50 grams. So 1 mole of calcium carbonate is 50 grams, 100 grams actually. So equivalent weight of calcium carbonate for 1 mole, equivalent weight of 1 mole of calcium carbonate is equal to 50 grams. So degree of hardness of water is nothing but the number of parts of mass of calcium carbonate, the number of parts of mass of calcium carbonate present in 1 million parts, that is 1 million parts by mass of water. So number of more parts of mass of calcium carbonate present in 1 million parts by mass of water is simply called as hardness of water, and this number of parts of calcium carbonate should be equivalent to various calcium and magnesium salts. What are the salts present in 1 million parts of water? So already how what causes hardness of water? Due to the presence of salts of calcium and magnesium. So I'm writing it in a separate slide, so please take it out. So let us see now. So here we can say hardness of water, hardness of water is due to hardness of water is due to the presence of chlorides, comma bicarb sulfates and bicarbonates, chlorides, sulfates and bicarbonates of magnesium and calcium. So therefore we can say 50 grams of calcium carbonate. So let us see calcium carbonate we'll forget. First we'll see, I'll give one equivalent relation. This is very, very important for doing numericals. So please see here. So equivalent relation between calcium carbonate and salts of calcium and magnesium, between calcium carbonate and salts of calcium and magnesium. So we can write equivalent weight of calcium. So this is very, very important. You can just see here now. So what is this relation? You can see here now. Equivalent weight of calcium carbonate is equivalent to equivalent weight of magnesium chloride also equivalent to equivalent weight of calcium chloride also equivalent to equivalent weight of magnesium sulfate also equivalent to equivalent weight of, means we have to equate all these things, equivalent weight of in 1 million parts of water, in 1 million parts of water, equivalent weight of calcium sulfate also equivalent to equivalent weight of magnesium bicarbonate, that is MgHCO3 taken twice, also equivalent to equivalent weight of calcium bicarbonate, that is CaHCO3 taken twice. So we have to compare equivalent weights. So by this you can say therefore 50 grams of, because equivalent weight of calcium carbonate is 50 grams, is equivalent to equivalent weight of magnesium chloride. So let us see, magnesium chloride is Mg. Mg is how much? 24. 24 plus 71, it is equal to 95. Equal to how much? 95. This is magnesium chloride. So 95 grams. So equivalent of magnesium is equal to 95 by 2. That is 95 by 2 means 95 by 2, it is equal to 47.5. 47.5. So we can say equivalent of making 47.5 grams of magnesium chloride. Why we have divided with 2? Because the charge of magnesium is also 2. Also equivalent to calcium chloride is 111. 111 by 2, 55.5 grams of calcium chloride. Also equivalent to magnesium sulfate. Mg is how much? 24. Sulfur is 32. Oxygen is 64, 64. So 4 plus 2, 6, 6 plus 4, 10. So it is equal to 120. So 120 is equal to 60 grams. 60 grams. This is 120 grams is magnesium sulfate mass. 60 grams of magnesium sulfate also equivalent to 40 plus 32, 72, 72 plus 64. 72 plus 64 is 6, 30, 136, 136 by 2. So that is calcium sulfate we can take, also equivalent to 136 by 2 grams, 136 by 2 grams of calcium sulfate also equivalent to, these are all equal we have to take, also equivalent to equivalent weight of magnesium carbon. Magnesium is 12, hydrogen is 1, 2, and 2 ones are 2. So let us see, hydrogen 1, carbon 12, 12 plus 1, 13, 13 plus 16, these are 48, 48 plus 13 is nothing but 53. 48 plus 13 is 63, 63 into 2. So here I am calculating the magnesium bicarbonate weight. So 24 plus 63 is equal to 87 plus 63, 150. So 150 by 2 is equal to 170, 75 grams. 75 grams of magnesium bicarbonate also equivalent to 40 plus 63, 103, 63 plus 63, 106 plus 40, 63, 126 plus 40 equal to 166. So 166 by 2, 166 by 2 grams of calcium sulfate. So this is called equivalent relation between calcium carbonate and salts of calcium and magnesium. So equivalent weight of calcium carbonate is equal to equivalent weight of magnesium chloride, which is also equal to equivalent weight of calcium chloride, which is also equal to equivalent weight of magnesium sulfate. So all the salts of that is hardness, which is causing hardness, that is calcium and magnesium salts, is equivalent to equivalent weight of calcium carbonate. So what is the equivalent weight of calcium carbonate we got? Is equal to 50 grams. So 50 grams of calcium carbonate is equal to 47.5 grams of magnesium chloride, 50, which is also equivalent to 55.5 grams of calcium chloride. That is nothing but 1 mole by molecular weight by 2. So we have to calculate the equivalent weights of all these salts, and that should be equated to 50 grams of calcium carbonate. So this is called equivalence relation. Very, very important. So this relation you have to note down in your classwork. This is complete relation of, that is 50 salts. That is complete salts here is the relation, very, very important. So please make a note. Now, how to do numericals from this? Let us explain now. So I'll explain the numericals part now. Let us see question number 1. So numericals on hardness of water. So basically what is hardness of water? It is nothing but the mass of calcium carbonate present in 10 to the power of 6 parts of water. numericals. So on hardness of water, very, very important. You'll get these numericals for JE mains and JE advanced. So how to calculate hardness of water in a given sample of water? Let us see now. So question number 1, calculate calculate the degree of hardness of water, hardness of water, calculate the degree of hardness of water in a sample containing in a sample in a sample containing in sample containing 222 222 ppm of parts per million of calcium chloride, CaCl2. So they are given 222. So from the equivalent solution. So how to do the solution for this? Let us see the solution now. Solution. How to solve this type of questions are most important for JEE Mains in advance. So how to calculate the degree of hardness in a given sample of calcium chloride? So it means we have to find in this hardness of water, we need to find the amount of calcium carbonate. We need to find a mass of calcium carbonate in the given sample. Just we need to find mass of calcium carbonate in the given sample. So it's very simple now. Therefore, from the equivalence relation, we can say, from the equivalence relation, we can say 50 grams of calcium carbonate, sorry, because the equivalent weight of calcium carbonate is equivalent to, so what is the mass of calcium chloride? It is equal to 155 point, so it is equivalent to 55.5 grams of calcium chloride. So implies 222 ppm of calcium chloride contains how much? So it is equal to, implies 222 into 50 divided by 55.5, which is coming around 200 picometers, because this is one time, this is four times. So 4 into 50 is equal to 200 ppms. So in the given water sample, calcium carbonate amount is 200 ppm. So degree of hardness of water is equal to calcium mass of carbon carbonate. Since the degree of hardness of water is equal to mass of calcium carbonate present in the given sample, so since mass of calcium carbonate is 200 ppm, so degree of hardness is equal to 200 ppm. Therefore, degree of hardness is equal to 200 ppm. Degree of hardness is equal to 200 ppm. Like this you have to consider. That's all. So basically the principle of equivalence is very, very important. So in that case we have to take principle of equivalence is nothing but it is assumed that the equivalent mass of 1 mole of calcium carbonate is equal to equivalent mass of 1 mole of calcium sulfate or calcium bicarbonate or magnesium chloride, calcium chloride or magnesium sulfate or magnesium bicarbonate. So that's why the degree of hardness of, to find degree of hardness of water, simple, we need to find only amount mass of calcium carbonate present in that sample. So mass of calcium carbonate present in that sample, to calculate we have to take the theory of equivalence. So according to theory of equivalence, the equivalent weight of 1 mole of calcium carbonate should be equal to equivalent weight of 1 mole of calcium chloride. So equivalent weight of calcium carbonate is equal to 50 grams and equivalent weight of calcium chloride is equal to 55.5 grams. So in the given sample, so for 50 grams, it is equal to 54.5 grams. So for 222 ppms, for 222 parts per million, how much it should be? So it is coming around 200 parts per million. So the answer is the degree of hardness of water in this sample is 200 ppm. Since water sample is having 200 ppm, it is harmful to use because it is exceeding 150. So it is very harmful to use. So I hope you understood this question. Next, question number 2. Like this numericals you will get in the examination. So let us see question number 2 now. Very, very important. The degree of calculate. Next model. Calculate the degree of hardness of water. Degree of hardness of water. Degree of hardness of water in a sample. In a sample containing. In a sample containing hardness of water in sample containing 36 milligrams of magnesium carbonate, 36 milligrams of magnesium sulfate, magnesium sulfate per kg of water. This is very, very important. Per kg of water. But our comparison is per million parts of water. So we have to convert this kg of water to million parts. So this is the question. Now, in this also, in any given question, we have to find the equivalent, we have to find the amount of calcium carbonate present. If we find the amount of calcium carbonate present in the given sample, that is nothing but hardness of water. So I'm writing here the hint. If you find to find amount of or mass of calcium carbonate present in the sample, calcium carbonate present in the sample, present in the sample. That's all. If you find this, this is more than enough. Now let us see solution. Let us see the solution. So it is nothing but for the given sample 10 to the power of 3 grams of or 10 to the power of 3 ml because 1 liter or 1 kg is equivalent 10 to the power of 3 ml of water contains 36 milligrams of magnesium sulfate. 36 milligrams of magnesium sulfate. This is given. So first we need to find for 10 to the power of 3 grams. For 10 to the power of 6 grams or 1 million because we have to take the consideration for 1 million part of water. It contains 36 into 10 to the power of 3. 36 milligrams in 10 to the power of 3 milligrams is nothing but equivalent to 36 grams of magnesium sulfate is present. How much grams of magnesium sulfate is present? 36 grams of magnesium sulfate is present. So, from the theory of equivalence, therefore, 50 grams of calcium carbonate, because first we have to convert the given per kg they have given. So, we have to convert for per million parts of water. So, per million parts of water means you have to multiply with 10 to the power of 3. So, 36 in milligrams into 10 to the power of 3 is equal to 36 grams because 1 milligram is equal, since 1 milligram is equal to 10 to the power of 3 minus 3 grams. So, we can take this. So finally we got how much sample in the given sample, how many grams of magnesium sulfate is present? 36 grams of magnesium sulfate is present. So 50 grams of calcium carbonate is equivalent to, from the theory of equivalence, we can say magnesium sulfate molecular weight is 120. So it is equal to 60 grams. So 60 grams of magnesium sulfate because magnesium sulfate molecular weight is 120, 120 by 2. So by this you can say 36 grams contains 36 grams of magnesium sulfate contains how much? So it implies 36 into 50 divided by 60. So 0 gets cancelled, 6 are 36. So 6 5 is 30. So answer is 30 ppm. It is safer using as domestic purposes. So this is the answer. So in the given numerical, if you find that amount of mass of calcium carbonate present in the given water sample, it is nothing but hardness of water. That's why you can say the degree of hardness of water is nothing but it is defined as the amount of calcium carbonate present in 10 to the power of 6 parts of water. Amount mass of calcium carbonate present in 10 to the power of 6 parts of water is called as degree of hardness of water. Very, very simple. So next question, let us see question number 3 in this. Next question number 3 is here now. Calculate a sample of hard water contains a sample of hard water, a sample of hard water contains a sample of hard water contains 1 milligram of, they are given here in this numerical 2, 1 milligram of calcium chloride and 1 milligram of magnesium chloride. Magnesium chloride per liter. Here, this is also very important. Per liter. Liter means 10 to the power of 3 ml. We have to make it in 10 to the power of 3. So, calculate the hardness of water. Calculate the hardness of water. Calculate the degree of hardness of water. That's all. Calculate the degree of hardness of water. Degree is a question. So, now we will take the solution first. So first, a sample of hard water contains 1 milligram of calcium chloride and 1 milligram of magnesium chloride per liter. Liter is important. So we can say 10 to the power of 3 ml of water sample contains 1 milligram of magnesium chloride plus 1 milligram of calcium chloride. So by this we can say 10 to the power of 6 ml because we have to take 1 million parts. 10 to the power of 6 ml of water sample contains 1 into 10 to the power of 3 milligrams of magnesium chloride plus 1 into 10 to the power of 3 milligrams of magnesium calcium chloride. So by this you can say it contains 1 gram of magnesium chloride plus 1 gram of calcium chloride. So let us find amount of calcium carbonate. Therefore, equivalent weight of calcium carbonate is equal to, mass of calcium carbonate mass of So from the standard comparison, we know principle of equivalence. We can say 50 grams of calcium carbonate is equivalent to magnesium chloride. What is the mass of magnesium? Magnesium is 24 plus 71, 95 by 2 equal to 47.5 grams of magnesium chloride. So implies, first separately we'll find, then we'll add these two. So 1 gram given is how much? So implies 1 into 50 divided by 47.5 is equal to 1.05 ppms. 1.05 ppms. Next, similarly, 50 grams of calcium carbonate. So I'll do it in next continuation. So we have found the amount of calcium carbonate in given mass of magnesium chloride. Now we'll find amount of calcium carbonate in calcium chloride also. So 50 grams of calcium sulfate, continuation, 50 grams of calcium carbonate is equivalent to, so the mass of calcium chloride is equal to, calcium chloride mass is 111 by 2, 111 by 2. So it is nothing but, because mass of calcium chloride also we have to take, calcium is 40 plus 71, 111, 111 by 2, 111 by 2 is equivalent to 55.5, 55.5 grams of calcium chloride. Implies for 1 gram of calcium chloride is equal to how much? Implies 1 into 50 divided by 55.5, which is equal to 0.90 ppm. So by this we can say, therefore degree of hardness of water in the given sample is equal to degree of hardness of water is equal to 1.05 with respect to magnesium chloride plus 0.90 with respect to calcium chloride, which is coming around 1.95 parts per billion ppm. In this way, you have to solve. So, in the given sample, we have to find simply only the amount of calcium carbonate in 10 to the power of 6 parts of water. We have to see that it should be 10 to the power of 6 parts of water, not 1 liter of water or 1 kg of water. It should be 10 to the power of 6 ml of water or 1000 liters of water. Then only you will get correct. So, in this way, you have to do the degree of hardness of water. So, let us take last example. I'll take in first page, question number 4. So with this, we can finish up this concept. Then we can go for another concept. So it is equal to how much? 1.95 ppm. A water sample. A water sample. These numericals are very, very important for JEE mains and advanced. Also NEET also. A water sample is found to contain is found to contain water sample is found to contain 96 parts per million of sulfate ions and 122 parts per million of bicarbonate ions and with calcium ion as only the cation, with calcium ion as the only cation. Means they are given it contains 96 ppm of calcium sulfate and 122 ppm of calcium bicarbonate they are given. That's all. Calculate the calculate the calculate the degree of hardness of water. Degree of hardness of water. So first case, we can say solution. Now you can see here directly they are given ppms. So ppm is not to convert anything. So from the principle of equivalence, we know 50 grams of calcium carbonate is equivalent to calcium sulfate 40 plus what is the molecular weight of calcium sulfate? We can say here it is calcium is 40 and sulfur it is 32, 72, 72 plus 64, 72 plus 64. So we can take calcium sulfate because first one they are given calcium sulfate and second one they are given calcium bicarbonate. So calcium sulfate molecular weight if you take into consideration, calcium is 40 plus because calcium sulfate we have to take calcium sulfate CaSO4 40 plus 32 72 72 plus 64 72 plus 64 is the molecular weight of that is 136 136 by 2 divided by 2 is 136 divided by 2 is equal to 68. So 50 grams is equal to 68 grams of calcium sulfate. Then implies how much they have given 96 ppms is equal to how much. So implies it is equal to 96 into 50 divided by 68 which is equal to 96 into 50 divided by 68 is equal to 96 into 50 divided by 68 that is equal to 4800 divided by 68 which is coming around 70.5 which is coming around how much 70.5 ppm. Similarly, amount of calcium carbonate in second sample that is 50 grams of calcium carbonate is equivalent to calcium bicarbonate. Calcium bicarbonate is dash grams of calcium bicarbonate. Calcium bicarbonate. Bicarbonate is 63 into 2, 126 plus 40. So 126 plus 40, 166. 166 divided by 2 is equal to 83. So 83 grams of calcium bicarbonate. So implies How much given? 122. 122 parts per million of calcium ions is equal to how much? It is equal to 122 into 50 divided by 83, which is coming around 122 into 50 is equal to 6100 divided by 83, which is equal to 73.4. So therefore, so here itself I'm writing, therefore decay of hardness of water is equal to, here I'm taking one more column, therefore decay of hardness of water, degree of hardness of water is equal to how much it is? 70.5 plus 73.4 is equal to 70.5 plus 73.4, which is coming around 143.9, 143.9 approximately parts per million. 143 point parts per million. Like these questions you get. So this is the example. So it is total, it is equal to 143.9 parts per million. 143.9 parts per million. I hope it is clear now. So like these questions you are expected for JEE Mains and JEE Advanced. So based on how to calculate degree of hardness of water is nothing but to calculate degree of hardness of water. It is very, very simple. To calculate degree of hardness of water, simply we have to find the amount of calcium carbonate present in the given sample of water. The amount of calcium carbonate present in the given sample of water. And how to find amount of given mass of calcium carbonate present in the given sample of water? By applying equivalence theory. So equivalent weight of 1 mole of calcium carbonate should be taken as equivalent weight of 1 mole of calcium sulfate, or also equivalent weight of 1 mole of calcium bicarbonate, are also equal to equivalent weight of calcium chloride also. So like this you have to do standard comparison. Then you can find the amount of calcium carbonate present in the given sample. If you find the mass of calcium carbonate present in the given sample, it is nothing but degree of hardness of water. It is nothing but what? Degree of hardness of water. So in this way, we have to calculate degree of hardness of water. It's very, very important. So please note that. Now, so this topic is finished. So next topic I'll start now. So please listen carefully. So I'm taking slide share again. So let us start now. So since we have completed degree of hardness of water, next concept is from this we have to do very, very important last topic in this chapter, that is hydrogen peroxide, preparation of hydrogen peroxide. So this is the last concept in this chapter. So hydrogen peroxide is very, very important. You will expect a question from hydrogen peroxide, and then we'll do the previous competitive questions as well as the summary of the chapter. So coming to hydrogen peroxide. So how hydrogen, so in this we are going to learn about preparation of hydrogen peroxide and also its properties, chemical properties and uses. So first one from sodium peroxide, Merck's method. It is also called as Merck's method from sodium peroxide. So calculated amount of sodium peroxide, that is Na2O2, is gradually added to an ice cold solution of 20% sulfuric acid. 20% concentrated sulfuric acid. This is 20% means 20% concentrated sulfuric acid. Ice cold solution of concentrated sulfuric acid 20%. Then by adding these two, you'll get sodium sulfate along with hydrogen peroxide in a small lots of constant stirring. So the equation here I'm writing, if it is not clear, so it is Na2O2. This is called sodium peroxide. On reaction with sulfuric acid, it forms sodium sulfate along with hydrogen peroxide. This equation is very, very important. So this is called sodium sulfate along with hydrogen peroxide. So calculated amount of sodium peroxide is gradually added to an ice cold solution of 20% sulfuric acid. So sodium peroxide is added to sulfuric acid, which forms sodium sulfate along with hydrogen peroxide. So this reaction is also called, this process is called as Merck's method. So this is the laboratory method of preparation of hydrogen peroxide. Next, we have second one. Next, upon cooling, crystals of sodium sulfate separate out and the resulting solution contains about 30% of hydrogen peroxide. So this is called 30% hydrogen peroxide, 30% concentrated hydrogen peroxide solution. The solution also contains some dissolved sodium sulfate, but it does not interfere with the reactions of hydrogen peroxide. So a pure sample of hydrogen peroxide may, however, be prepared by vacuum distillation. So whatever the hydrogen peroxide we got from this sample is only 30% pure. So to make it 100% pure, so we have to do it by vacuum distillation. So it is prepared by vacuum distillation. I hope it is clear. So this is the preparation of hydrogen peroxide. Simple it is. It is also called as MEX method. Calculated amount of sodium peroxide is gradually added to, sodium peroxide is added to sulfuric acid, 20% sulfuric acid solution. Then we will get a mixture of sodium sulfate and hydrogen peroxide. Whatever the hydrogen peroxide formed in the above mixture contains only 30% purity. And to make it 100% pure, we have to do vacuum distillation. Vacuum distillation. And the solution separates, sodium sulfate can be separated and our resulting solution contains about 30% of hydrogen peroxide. So this is called MEX process. Next continuation. Second method from barium peroxide. Barium peroxide. So hydrogen peroxide is prepared from the barium peroxide by the following methods. First method, by the action of dilute sulfuric acid. By the action of dilute sulfuric acid. So a paste of hydrated barium peroxide, BaO2, barium peroxide. Only peroxides, only we are getting hydrogen peroxide, mind it. So a paste of hydrated barium peroxide is prepared in ice cold water and then added slowly to an ice cold solution of 20% sulfuric acid. So again, this is also added to 20% sulfuric acid. Then it forms. So the equation is barium peroxide dot 8H2O plus sulfuric acid gives rise to barium sulfate precipitate. It is white in color. Barium sulfate precipitate plus hydrogen peroxide plus water. That water has been evaporated, 8 moles of water. So simple it is. So this is the equation. Since it is not clearly typed, so that's why I have written it separately. So barium peroxide, hydrated barium peroxide is nothing but a paste of hydrated barium peroxide is prepared in ice cold water and then added slowly to an ice cold solution of 20% sulfuric acid. Here also it forms a precipitate of barium sulfate. Since it is precipitate, it can be filtered off, and hydrogen peroxide and water. The white precipitate of barium sulfate is removed by filtration, leaving behind a dilute solution of 5% hydrogen peroxide. So only we are getting 5% of hydrogen peroxide. In this method, anhydrous barium peroxide cannot be used since the precipitated barium sulfate forms a protective layer around unreacted barium peroxide, thereby preventing the further reaction. So that's why we have to use only hydrated barium peroxide. Why we have to use only hydrated barium peroxide? Because if you use anhydrous barium peroxide, it can, since it will precipitate the barium sulfate forms, the barium sulfate forms a protective layer around unreacted barium peroxide, thereby preventing the further reaction. So this is the limitation. Now, hydrogen peroxide prepared by this method contains appreciable quantities of barium ions in the form of dissolved barium sulfate, which catalyze the decomposition of hydrogen peroxide. Therefore, H2O2 prepared by this method cannot be stored for a long time. Further, H2SO4 acts as a catalyst for decomposition of hydrogen peroxide. So it acts as a catalyst for the decomposition of hydrogen peroxide. So that's why this reaction we have to do it quickly and it cannot be stored more for a long time. So this is for the first preparation of from hydrated barium peroxide. Let us go now second preparation. Next, by the action of carbon dioxide. By the action of carbon dioxide on barium peroxide. So when a stream of carbon dioxide is bubbled to a thin paste of barium peroxide in ice cold water, hydrogen peroxide and barium carbonate are produced, and the barium carbonate is in precipitate. So the insoluble barium carbonate is removed by filtration, leaving behind a dilute solution of hydrogen peroxide. So let us see the equation. So barium peroxide combines with carbon dioxide and water because we have to take ice cold water. It forms barium carbonate precipitate along with hydrogen peroxide H2O2 and also along with H2O2. So this barium carbonate precipitate is removed by filtration, leaving behind a solution of hydrogen peroxide. So this hydrogen peroxide. Next, by the action of phosphoric acid. Third preparation is by the action of phosphoric acid. Hydrogen peroxide can also be prepared by the action of phosphoric acid on barium peroxide. So let us see action of phosphoric acid on barium peroxide. So it is 3 moles of hydrated barium peroxide is to be taken. 3 moles of hydrated barium peroxide on reaction with phosphoric acid. The formula of phosphoric acid is H3PO4, which gives rise to barium phosphate Ba3PO4 taken twice. This is called barium phosphate precipitate along with hydrogen peroxide plus 24 water molecules because 3 moles of we are taking hydrogen peroxide. So in this way we have to prepare hydrogen peroxide. Barium phosphate precipitate is decomposed and dilute sulfuric acid to give phosphoric acid, which can be reused. So by this we can say preparation of hydrogen peroxide. So this is the third preparation. So total we have from barium peroxide we have 3 preparations, and from sodium peroxide we have 1 preparation. So total we have 3 preparations. Next, so this is the preparation of hydrogen peroxide. So now I'll take the new slides so that I'll write chemical properties of also hydrogen peroxide. So please listen carefully. Some more methods of preparation of hydrogen peroxide. So here I'm taking industrial method of preparation of hydrogen peroxide. Industrial method of preparation of hydrogen peroxide. Industrial method of preparation of hydrogen peroxide. Let us see now. Hydrogen peroxide is prepared industrial method by the electrolysis of, here I'm writing everything, so please make a note. By the electrolysis of 50% 50% solution of sulfuric acid, 50% solution of sulfuric acid, 50% solution of sulfuric acid we can obtain. So we can see here sulfuric acid is electrolyzed. Then after electrolysis it forms what? H plus ions, 2H plus ions plus sulfate minus ions. You can say bisulfate ion minus. At cathode, this 2H plus ions gains 2 electrons and becomes hydrogen gas. At anode. So here it is bisulfate ion it is forming. So H plus ion and bisulfate ion. At anode, this bisulfate ion, 2 moles of bisulfate ion we can take. So if we take 2 totally, so here also you get 2. So 2 moles of bisulfate ion changes to oleum, that is H2S2O8, by losing 2 electrons. That is oxidation takes place. And this water, so this oleum formed at anode is combined with water in the presence of dilute sulfuric acid, and forms H2SO5, and forms hydrogen peroxide H2O2 plus H2SO4. So in this way we prepare hydrogen peroxide. So by the electrolysis of 50% of solution of sulfuric acid, So sulfuric acid on electrolysis forms H plus ions and HSO4, that is bisulfate ion. So at cathode, H plus ion changes to form hydrogen gas. At anode, bisulfate ion changes to H2S2O8. This H2S2O8 combines with water and forms hydrogen peroxide along with sulfuric acid. So this is called industrial method of preparation of hydrogen peroxide. Industrial method of preparation of hydrogen peroxide. So let us take now one more method of preparation of hydrogen peroxide. This is also very important. By the This method is very important. You can see here by auto oxidation. Oxidation by auto oxidation of 2-ethyl anthraquinol, 2-ethyl anthraquinol, anthraquinol by auto oxidation of 2-ethyl anthraquinol. Hydrogen peroxide is also prepared by the auto oxidation of 2-ethyl anthraquinol. So this process involves a cycle of reactions. So you can see here 2-ethyl anthraquinol. So this is a big structure. Let us see the structure now. Three benzene rings are fused together. Three benzene rings are fused together. Benzene rings. So here you can say, instead of taking round, I keep double bonds. Then only it is easy for us to understand. First double bond, alternate double bonds. Then this is common to both. So here we keep double bond here. And next we have double bond here. And next we have double bond here. Double bond here. So it is OH. And this is OH. This is also double bond here and double bond here. This is becoming C2H5. So this is called 2-ethyl, second position ethyl anthraquinol. Quinol means 2 OH groups on oxidation. On oxidation means addition of oxygen gas. On oxidation, it forms just nothing is there, same compound. Same compound is formed. Three benzene rings fused together, but only hydrogens will come out of this. So same double bond positions. You can take here the double bond position, and double bond position. And also here the double bonds are same. And this becomes double bond O, double bond O. So inside double bonds will, the position of double bonds will change. So you can see here. So double bond O, double bond O. So here you'll get one double bond, here you'll get one double bond, that's all. So this is called 2-ethyl anthraquinone, 2-ethyl anthraquinone. Quinone means ketone group, ketone, double bond O, and ethyl is same, C2H5, plus these two hydrogens which we have removed from this will form combined with oxygen form hydrogen peroxide. This is called auto oxidation of 2-ethyl anthraquinol. So this the compound is called 2-ethyl, second position carbon is there, so 2-ethyl anthraquinol. Anthraquinol changes to 2-ethyl anthraquinone plus hydrogen peroxide. So this is called preparation of hydrogen peroxide. This is called what? Preparation of hydrogen peroxide. So method for concentration of hydrogen peroxide and chemical properties of hydrogen peroxide we have, that we'll finish up in the last hour, in the next lecture. So with this, I'm ending this session. So all these questions are very important. So by the auto oxidation of 2-ethyl anthraquinone, by the auto oxidation of 2-ethyl anthraquinone, this is the last preparation of hydrogen peroxide. So in this lecture, we have done degree of hardness of water, numericals based on degree of hardness of water, and also preparation of hydrogen peroxide, only preparation of hydrogen peroxide. In the next session, we'll do chemical properties of hydrogen peroxide, chemical properties of hydrogen peroxide, along with summary of the chapter, along with some questions. Then we can end up this session with this chapter will be finished. So I hope it is clear. So I'm ending this session. Thank you.